It's Mrs. Davitt here, and today I am going to use the illustrative math GeoGebra geometry tools to help convince us of the triangle angle sum theorem. Now, the triangle angle sum theorem states that the sum of the three angles in any triangle is 180 degrees. So we can do a couple things in our tools here to convince ourselves of this. So to start, I'm going to draw a triangle. Any triangle will do. So I'm going to grab my polygon tool and construct my triangle. Now once I have my triangle here, I want to label the insides of these angles with a lowercase a, b, and c. And that's just going to represent the measurements of these angles, which we don't know right now, but we're hoping to convince ourselves that no matter what those measurements are, that they add up to 180 degrees. The next thing I want to do is mark the midpoint of each of these sides of the triangle, these two sides. So if I look under my construct tools, sure enough, there is one called midpoint that will mark the exact midpoint of this segment here and this segment here. Great. The next step is to add a line extending through side AC, the side that we did not mark the midpoint on. So we can see one line, our triangle, the midpoints of the sides, and the three angles. Now, based on our previous lesson, I can rotate that line 180 degrees about the midpoint, and perhaps you can imagine where that will land. Well, it should land on the other side of the line, hopefully passing through point B, and it should land also so that it is parallel to the original line. Now, how do I know that? Well, we saw that during our rotations lesson, that if we rotate 180 degrees around some point beyond the line, we should create a parallel line. So I'm going to grab my rotate around a point tool for my transformations. I'm going to click the line that I want to rotate. Either of the midpoints is fine here. And I'm going to rotate 180 degrees. And ta-da, we have formed a line going through point B that runs parallel to line AC. Now, why is this special? Well, in our previous lessons, we talked about a bunch of different angle relationships. We talked about vertical angles, we talked about corresponding angles, we talked about alternate interior angles, and several more. Okay. Well, looking at this diagram here, I should be able to see some pairs of alternate interior angles. And that should help me determine these missing angles up here. Well, what angle is this alternate interior angles with? It's angle C, right? So I can go ahead and grab my text box, and if this is some measurement C, and this is the alternate interior angle, we know that alternate interior angles are congruent when lines are parallel. So since I've created parallel lines, I know that the measure of that angle is also C. Now, by the same logic, I can fill in this missing angle. What letter does that match up with in terms of alternate interior angles? You got it, it matches up with the A. So I can go ahead and place an A there to represent the measure of that angle. At this stage, I have three angles labeled at vertex B, which all together form a line. Now, we know that at one point along a line, the angles should add up to 180 degrees. So that means that A, B, and C all together add up to 180 degrees. How do I write that? I write A plus B plus C, the sum of those three angles, equals 180 degrees. And so that is one way to convince ourselves of the triangle angle sum theorem, that the sum of the three angles in a triangle, A, B, and C, add up to 180 degrees. Now let's rewind a couple steps and see if we can look at this a different way. So I'm going to get rid of some of these markings here. We're going to go right back to when we just had our triangle. And now we're going to envision this, instead of with rotations, we'll look at translations. So I'm going to go ahead and grab my translation tool, and I'm going to translate this triangle along vector BC. So I'll go ahead and draw that vector, and boom, there's my triangle. Now this new image triangle, I'm going to translate one more time along vector A prime C, which is now also labeled A prime B prime. Okay, and now I have three triangles here, and I'll try to get us a little bit of a better view. And we should be able, again, to use some of the angle relationships we know to fill in some of these missing angles. Now, Translations create parallel lines. So again, we can use any of the angle relationships we know that happen as a result of parallel lines. We also can use the fact that when you do a translation, the angles in the image shape remain the same, right, as the angles in the original shape. So if I wanted to, I could fill in these three angles as A, B, and C. And I could do the same thing for the third triangle. Okay. I also can use my parallel lines, like I said before. So this angle here would be alternate interior angles with this angle here. So since those lines are parallel that we're forming with the translations, that would also be B. Now, if you didn't see those alternate interior angles, don't panic. You could use your vertical angle trick right here, right? And that could tell you if this is angle B, then this would also be B. Again, using our translations, we can see that these three angles will be the same as the original three angles, so I can label these A, B, and C. And using a whole bunch of angle relationships, there's a lot of ways that I could label these missing angles. Now, I could keep going for a while using vertical angles or corresponding angles or alternate interior angles, but at this point, look at this, A, B, and C all lie along a line at point, it used to be point C, now it's A double prime because there's a couple transformations that have happened right on top of that point. So we should feel convinced that A plus B plus C equals 180 degrees. So those are two ways for us to convince ourselves of the triangle angle sum theorem. I hope you're convinced at this point that the sum of the three angles in a triangle will always be 180 degrees. Thanks for watching.